Okay, so let's continue our discussion of free fall problem. So let's have our last example. So here we have an object dropped from a hot air balloon 300 meters above the ground and rising at a rate of 13 meters per second. So we are going to determine how fast the object is going when it hits the ground. Okay, so in this example, you have to consider that you don't only have an object, but you also have a hot air balloon which is moving. Okay, the hot air balloon is actually moving at a rate of 13 meters per second. So the object is, okay, assuming that this is the object is in the hot air balloon. So it means that whatever is the speed of the balloon is the same, or whatever is the velocity of the balloon is the same as the velocity of the object. Okay, so unlike in the previous examples wherein we considered our initial velocity for downward motion as 0 because objects are released from rest, this one will have a certain value for the initial velocity because the object is moving together with another object. Okay, so as this object falls down, we will try to determine its final velocity, or v sub 2, just before it hits the ground. Okay, so let's write all our given. So again, our initial velocity is the same as the initial velocity for the balloon. It's 13 meters per second. Okay, we are given a distance or height of 300 meters. We are given our acceleration due to gravity, which is 9.8 meters per second square, and we are going to determine the final velocity. Okay, take note also that the object is in downward motion. Okay, so if it's a downward motion, okay, we will consider all our given as negative, okay, for all because of the direction. Okay, now, in the set of equations that was shown to you in the previous videos, there is one equation that we can use to be able to solve for the final velocity. So our variables are v sub 1, d, g, and v sub 2. So in our set of formula, okay, the last equation for distance, which is d equals v sub 2 squared minus v sub 1 squared all over 2 times g can be used. Okay, however, we should derive the equation so that we can get the formula for our final velocity squared. Okay, so to do that, we will transform the equation into linear form. So d here is understood to have an invisible denominator of 1. So we are going to cross multiply them. And when we cross multiply them, you have d and 2g. So it will become 2gd equals v sub 2 squared minus v sub 1 squared. Okay? So we need v sub 2 squared. We have to remove or isolate, or we have to isolate v sub 2 squared. So we have to remove negative or minus v sub 1 squared. So we will do that by, okay, by adding v sub 1 squared or positive v sub 1 squared to both sides of the equation. So that we can cancel minus v sub I squared here, okay, together with v sub 1 squared. Okay, so there. So our equation now will become v sub I squared plus 2gd equals v sub 2 squared. Further simplifying, we have to remove the square, so we will be putting a square root. Okay, so that we can cancel it. And then if we cancel it and if we rearrange our formula, it will now become v sub 2 equals the square root of 2gd plus v sub 1 squared. Okay, so we will be using this, okay, we'll be using this formula to be able to solve for our final velocity. Okay, so let's substitute our given. So we have 2 multiplied by negative 9.8 meters per second square. Okay, and then our distance is negative 300 meters. Okay, negative 300 because it's downward, no, it's considered to be displacement. And then plus our velocity, which is 13 meters per second. We will also take note, or we will also be using negative 13 meters per second, and then we will be squaring that. Okay. If we multiply 2 by 9.8 and by 300, we will get 5,880. Okay, and then the units, we cannot cancel meter and meter here because both of them are numerators, so we will have meter squared over second squared. Okay, plus this is 13 squared. So if we get the square of 13, we will get 169. Okay, and the unit is meter square per second square. Okay, and then simplifying, getting the sum of 5,580 and 169, you will have 6,049 meters square per second square. Okay, and then if we get the square root of 6,049, our final velocity will be 77.78 meters per second. Okay, so there.